Hi and welcome to another Syvecs help video. This help video is on how to set up a power distribution unit with our engine control units. In question, the actual ECU that we've got here on our rig and the power distribution unit we've got is an S7 Plus and a PDU X3. Now the first thing to go over is actually just to illustrate some of the aspects of the communication structure in terms of wiring. Now what you can do is both of these units have their own Ethernet connections, and these Ethernet connections are used for communicating with either device. Now one beautiful thing with the PDU X is that basically it has an onboard Ethernet switch, so it has actually got two places where you can wire in an Ethernet connection into the multi-connector in the middle of the PDU. Another option which you can do if you have got one of the earlier PDU units, a PDU 10, 16, etc., is you can actually use an Ethernet switch externally. And a really good one to use, which is not expensive, is actually this Amazon D-Link DS10. Now I actually, DS105D, I actually have one of these units actually connected during this help video, so you can actually see how seamlessly it works. But it's a good thing to point out because it's a headache having to unplug Ethernet connections and go between each port. Wiring for the PDU can be found on our website in the download section, where you can actually then scroll down in the user manual and it will actually show you the wiring schematics for each item and each connector on the PDU. So one thing that's worth just pointing out while going over this pinout sheet is the actual output types and what they can be used for. Now, in case you're aware, the new PDU range, the PDU X and the PDU 32A, has the ability to basically allow you to have a slave connection to the ECU. Now what that means is you actually don't have to use the PDU setup software at all. You would get your PDU, you would simply wire in the slave connection to your ECU, and then actually the ECU side of the control is where you actually set up the outputs and inputs. It's quite useful. It's basically a nice way to actually go around an I/O expander, and the outputs are extremely capable in how much current and power they can hold. So sometimes if it is going into an application which does need high current, it makes sense to go with the PDU option instead of using an expander. Now going over this list on connector 1, you can see that the outputs, there's 20 outputs, and basically that you can see the signal notes. So outputs 1 through 10 have the ability to be high side, low side, they can be PWM, half bridge, full bridge. And what that means is that they are basically quite useful in terms of replicating the outputs we have on our engine control units. So if you were wanted to control a drive-by-wire using the PDU, you could basically use output 1 and 2, join the drive-by-wire motor together, and then assign it to the output slave output 1 in SCAL, and then basically set that up as a full bridge in the options, and it will automatically connect to it. And we'll go over that in a minute. The outputs 11 to 20, these are high side based, and these basically mean that when they're powered on, no matter what the configuration of the output type, it will literally just turn to go to 12 volts. Then on the multi-connector option, you can then see that there's lots of more options on here. There's more outputs, they don't handle as much current, and what you've then got is loads of inputs which you can wire in, etc. The CAN connections, the wake up pin, which is a dedicated pin for allowing the PDU to go into a low power state, which is really useful if used in road cars. And you've also then got the Ethernet switch, which we talked about before, so you can wire in one Ethernet connection and then wire in the other side of that. So one side to the ECU, one side to the computer, and basically you can use it as a switch. So it's really useful instead of having to have two Ethernet connections. So basically the ECU connection would go through the PDU, and then the other side would go to your computer. Now, one aspect which is also worth talking about is that you can actually have this set up also as a generic CAN-bus based. And what I'm going to actually go over now is just a picture here to show the different type of CAN connections. Now I know it's not my best piece of artwork, but it simplifies just and helps sometimes automatically realise with the different colours what you can have. So let's take the S7 Plus and S8 first. Those actually have two CAN buses on them, and generally CAN 1, if used in our kit format, is used for OEM ECU connections. Now with the S8, if you are using a CAN bridge, you could still use the CAN 1 to be as a generic aspect. But to keep this thing simple and basically thinking that you're actually going to be using it part of actual a plug and play kit, we're just going to go on the assumption that we're going to use CAN 2 for that with the S7 Plus and S8. So basically you've actually got two options here. Now if you want to have the slave connection, as I talked about before, some people prefer that. Me personally, I probably would prefer that. It's a nicer aspect of being able to control things more logically in the ECU. Then you would use basically the slave dedicated CanBus, which is on the PDU, which is CAN 2. So you'd wire the CanBus of CAN 2 direct to the say S7 Plus CAN 2, and then basically once you assign an item in SCAL to slave out, which we can do here if we just go onto here and actually go, so I'm using the first slave for the S7 Plus vehicle communications, so I'm then going to assign it to slave out 1 on slave 2, slave 1 out 1. You'll then see that I'm using slave 1 at the moment. If I program this and it comes online, you'll then see that it's actually grabbed communication with slave 2. Now if I actually, just one thing to be aware, if I actually assign this, and say if for example I was using the PDU software base, and you can see in here I've already set up an output to be assigned for the water pump in this particular application. One nice thing that you've got is if you are using the slave but you are setting some of the onboard controls via the PDU, if you were to assign that, basically once you assign it, you actually get an error to basically say, sorry, wrong slave there. Let's put it on slave 26. You actually get an error here in the bottom right hand corner to say that output is already used, it's an incompatible slave output. And what that means is it's basically used by something else. And in the PDU, when you connect to it on here as well, it will actually show you in the bottom right hand corner here, there's a slave link timeout, and it says here out 6 is used by the schematic, which is on board here, so it's not used by the slave. So that's just one thing to make sure that some people might worry that they're going to be using the output type for two things, and that's actually not possible. So let's come back to our image here. So basically, yeah, you've got your slave communication. If you don't want to have to use the slave, for example, communication of the S7 Plus, then you can use the generic. So basically, you basically wire in your CAN 2 from the S7 Plus direct to the CAN 1 on PDU. You can't use the CAN 2 because that's slave. And then what that would be then using is actually using the PDU control functions of the ECU, which you can see here, X PDU control 2, which I want to come over a bit later in this video, to basically use those to drive the outputs and also get information back into the ECU. The one benefit that you do have with the using the generic CAN is you can also receive all the currents over that CAN bus that is fed back into the ECU, which you can then punch out to a dash, etc. But that's not to say you can't do it with a slave, because with the slave what you could do is you could then not have the generic CAN connected to the ECU. So basically what you'd have is slave would be connected directly from the ECU to the PDU, and then as you can see here where I've got the orange, because these options, orange is one option, blue is another option, and green and red are another option as well. Where you've got the orange, basically you'd have the slave connected on the CAN 2 of the ECU, and then you could have the CAN 1 of the PDU going to the touchpad, or you could have that going to the dash. So you could actually you can have it going to the touchpad and the dash, so you can actually send out the current usage of the PDU for each output to the dash, and that could display that as well. So there's two options there to which way to go. It really comes down to what CAN buses you've got available and how you want to go about doing stuff. If you wanted to control an extra throttle body using the PDU, then you're going to have to use the slave option, because you can't do that via generic CAN. But likewise, if you're not wanting to do that and just simply for power control units inside the car, the generic CAN is quite a good way of doing it. And you can see how I've basically set that up. Then it goes from CAN 2 to CAN 1 on the PDU, and then what you would actually make sure is that the CAN would be terminated on one end of the PDU and the other end on the ECU, and then these nodes that come off, basically you want to make sure they're less than 8 inches in length to go to each of these items off the CAN chain. If you are, another way of doing it is obviously have the twisted pair of wires for the CAN, basically first going to the dash and then going back out, so you just don't have any interference on the CAN network. If you're using an S12, that actually has 3 CAN buses, so you can basically have both set up. You could have the generic CAN connected to the CAN 1 on the S12, and you could also have the slave connected on the S12 as well. So that's a nice option if you want to do that. And like I said, you can do that on the S8 as long as you're not using it for it's not using a plug and play kit, which is using the CAN 1 for the interface for the OEM car. So we've covered the slave communication protocol between the engine ECU and the PDU. Now is the time to cover the generic CAN, which is used between the PDU and ECU and other applications, which is generally used on CAN 1 of the PDU and say CAN 1 of an S8 or an S12, and on an S7 you would use CAN 2, as we talked about previously in this video. The generic CAN is more used for vehicle based logic, so that, for example, fuel pump, fans, etc. Anything that's like to do with engine control, like drive-by-wire, VVT, that needs to be done via slave because the control logic won't work on the generic bus. So let's have a look at first, just actually sending out to the ECU a switch, as such, a soft output. So what we're going to do is first of all go to Cal and then communication. And when we're in here, we're going to have a look at the output states. So we can see here that the output states 1 to 8, output OP, are going to be sent on the 718 frame. Okay, we need to make sure the baud rate matches. So the CAN baud rate here is 1 megabit. And if we come back to the ECU on here and go to CAN 2, we've got 1 megabit as well. So those match. Once we've done that, we then need to go back to our main actual page and actually set an output which we want sending to the ECU. We're going to click on this and change this to a soft output. Let's use soft output 4. I'm just going to put in here, test. Now once you've done that, you can then obviously link this to a button or for a state from the ECU, and you can have the keypad on the touchpad, and basically when that's pressed, it then sends this output to the ECU for like maybe a cal up switch or something like that. And we can see here that when we're highlighting over it, it says CAN 0x718 byte 4 of 8. So what we need to now do is actually go to the ECU side and set up the generic CAN receive to receive that message that's being sent from the PDU. Now, because the items that come from the PDU are just take up 8 bits, there's no point using the receive A items because they're for 16-bit bytes of data. So what we're going to use is we'll use receive B, and then we're going to go yes to receive B on B1 to 8. And then we're going to set the bus to be CAN 2 because that's what we're connected to on this S7 for the PDU. And the identifier then was 718H. Now the H basically at the end needs to be input to tell it that it's in hexadecimal. After we've done that, the timeout and initial timeouts generally can stay at the default values, and it's generally always a signed item. Now if we then go down to input configuration, and whatever that item that you've got on the PDU you want sending to the ECU, you then need to assign that in the ECU pin assignment. So we talked about it being a cal up switch or an ALS switch to enable anti-lag. So what you do with that, you then click on here and type in xcan, and then from here we receive, and basically because it was being sent on the byte 4 of 8, what we're actually going to do is reset this to xcan receive B4. Okay, now what that would do, the reason for that is because if it was sent on byte 1, it would use B01, because it would be the first byte in that actual frame, so on that bus, on the identifier. So basically on the 718 you can have 8 bytes, and then in the PDU you can send up to 8 soft outputs on that one identifier, and this one, because it was soft output 4, which is byte 4, we then just need to assign that in SCAL to match on this side. And you can basically go through that as many times to do so for other inputs throughout if you need. The generic receive B, you've obviously got up to 32 soft inputs theoretically that you can come from the PDU into the ECU. Now, once you've done that, another thing you can enable, you can go to the LR PDU CAN receive, and what you can do is when you set these to yes, you need to set the bus again. So you set this to yes, and then set the bus to CAN 2, and the base identifier. Now, in the CAL communication area, you can see the data stream base ID is 700. That's the default value. And the value which is in SCAL will be matching that generally. Now, you probably don't want to change that. If you do have something that's clashing with that 700, something else on the bus, then you can change that. But it's generally worth starting with a 00 as the base, because what it will do is the PDU will send up to 20 items of data, of frame data that contain all of the current values and status data from the PDU. So when you enable those, basically all of the PDU A pins will then be sent over, which would be all the way from PDU 0 or 1 all the way up to I think it's 48. So once you do that, it will pick up all of the HS outputs from the ECU and then send the current data into the ECU, which you can then use for data logging, sending to a dash, or use as on comp maps for custom features for etc. Okay, so that hopefully is pretty clear. Now we need to look at actually sending a CAN data to the PDU. So to do this, we need to actually use the generic CAN transmit area. And first of all, we need to make sure the transmit bus is set correctly, as we've gone over earlier many times. So that's all on CAN2. Now the transmit identifier. Now the identifier values that are in here are basically just the default values which are used by a lot of external companies for our custom CAN protocol. So it's probably best not to use these. What I would actually generally always recommend is the frames here from 0 to 20. I would leave alone. I'd actually do the side of things right at the other end of the transmit identifier. It keeps it separated from the actual main generic kind of custom CAN transmit that we have. So what we're going to do, we're actually going to use the 40 frame here. I'm actually going to use the 400 hex to do this. So I'm going to set here 400 hex. Now once you've done that, we need to set the frequency for this frame. So I'm going to set this at 100 hertz, which is more than ample enough for what we're actually going to use it for, so 100 times a second. And then on the transmit content down here on the 40 frame, we need to set the PDU control state. So we type in PDU and scroll down. And right at the bottom here, you can see we've got PDU control 1 and 2. And what I'm going to do is copy that into here, and then we can just press up on that to save having to scroll through the list. Okay, so what that means then is these 8 PDU control outputs we can now use for doing custom PDU functions. So once they're assigned in there, these outputs can then be assigned in the pin assignments. So if we go to pin assignments, and let's say we want to send out, let's have a look. Let's go fan 1, let's send that out on PDU. So just type in PDU control 1, fan 2, and go on PDU as well. Send that on 2, then fuel pump 1, send that out on the PDU 3, and so on. You can set those as you wish. Now you need to program the ECU for these changes to take account, and then after you've done that, you'd go to PDU Setup, and you can then pull that information into the PDU. So you go input, and on here this will be then assigned as a soft input. So soft input 1, and let's say this thing will be called a radfan 1. Now once you've done that, we need to go to CAL and communications and actually set our soft inputs to be on the same identifier. So we're going to use the 400 identifier, so put in there 400, and you'll see here then straight away CAN 0x400 byte 1 of 8 is going to be this soft input. Okay, so the first one we sent on the PDU is radfan. We've got that labeled, and what we can now do is use that to define for any custom features. So as you can see in this page I've got here, I've got like a soft input that comes in here, the radfan input from ECU CAN that goes into an XOR, and then you can use that to turn on fans, etc. So it's a very powerful tool for creating your own schematics as you are. This is obviously a bit more complicated, but you can just set up simple soft inputs to a latch and then to the output to basically achieve what you want. Or we can provide you with some example sheets to help you get going as well. Okay, so let's look at getting the keypad into the keypad switches into the ECU and how that's done. So on this particular application, just using a Greyhill keypad, The Greyhill keypad is actually been programmed already. We are looking to add in the communications part here the Greyhill programming button. So soon you'll find there'll be a Greyhill button here, an option to program the Greyhill switch panels. If not, then we can look at doing that for you to match the generic function of the Greyhill and can open. But that will come later, where we can actually do that for you in the software. If you've got just a lot of people have asked this, if you've got a Motec and ordered a Motec keypad, this actually comes programmed with the same generic Greyhill switch panel settings, so you can use that straight away to communicate with the PDU once you've ticked this option. Once you've ticked the Greyhill switch panel option, you've then got your switch base, which the generic values from the Greyhill panel are in the 500 hex range. So I've got it set as 506 on this. And then once you've got that, you can actually then set your inputs again to be based off that panel. So you can go to scroll to the bottom and you can see these switch inputs. So switch input 1 will be the top left button, and then switch input 2, the one next to it. And you can rename these to suit. So if we go to, for example, our lighting page here, you'll see that I've got the switch input 7 is side light. So when that's pressed, it will latch the output on, and I can actually show that easier. If we go to Cal and start simulation, not one input's been assigned. That is because on this page we have these, they're not assigned, so let's just delete those for now. Come back and start simulation, and then you can actually simulate what's going to happen. So when the keypad button is pressed on, you'll see that these latch to on, and then these outputs turn on. And what we've got here is the Greyhill LEDs that are set on the panel. So you've got 3 LEDs in the Greyhill panel, so you need to make sure that the GH1 output 7, so that's the button number 7, those 3 LEDs are assigned to this function here. And the switch then obviously matches that. So I basically got it set that if the outputs are on, it will basically come through here. So the latch state will turn them on, they come into here, and the orange and red LEDs will be lit to say that each one of those outputs is on. And then the flash statement here, this is an XOR. On the bottom of the outputs, we've got a fault pin. It goes into an XOR, and then it flashes in the event that there is a fault. So, and you can actually toggle the fault on here, and you'll see that that's then flashing on here, and that would then be causing to the green LED on the Greyhill panel to be actually flashing to indicate there is a fault with these outputs. Okay, let's clear that. Now, just to go over how you actually set these, because obviously I showed how you set the switch panel input. To actually set up these Greyhill outputs would be a output function again, and then you double click on it and scroll right to the bottom, and then you'll see these Greyhill outputs. So once you click on that, you can name this to the output you want. So Greyhill panel 11, and then it's pretty simple from there onwards. You can just assign then the which LED you want to turn more. Okay, hopefully this covers all the basis of getting you up and running and working with the PDU communications. Any more questions, feel free to email support@syvecs.com.